Most scrapers reach for a headless browser by default, and it is the single most expensive habit in this world. They spin up a full Chromium for a page that would have handed the same data to a plain HTTP request, then pay for that browser on every page forever. The real decision is not which browser tool to use. It is whether you need a browser at all, and most of the time you do not. Today I want to walk through how I decide, where the cost actually hides, and how I run a hybrid that stays cheap on the pages that allow it and only pays for a browser where the site truly forces one. I run production scrapers for a living, the kind that pull public data at scale every day, so I have paid the browser bill when I did not have to and felt it in the monthly invoice. I am going to keep this concrete and honest. There is no tool here that makes you undetectable, and the browser is not a magic key. There is a light cheap path and a heavy flexible one, and the whole skill is knowing which one a given page actually demands before you commit to it. The one test that decides it. Start with a single check that settles most of this. Open the page in your browser, view the raw source, and search that source for the thing you want to collect. If the price, the title, the number is sitting right there in the HTML the server sent, you almost never need a browser. If the source is a near empty shell and the content only fills in after the scripts run, then you need something that executes those scripts. That one look at the raw source decides the large majority of these calls, and it takes about 10 seconds to do. What an HTTP client actually does. An HTTP client is the simple side. It opens a connection, sends a request, and hands you back exactly the bytes the server returned. Nothing more. It does not run JavaScript. It does not build a page. It does not know what a button is. It is just a raw response. That is why it is so light. There is no browser eating memory, no rendering, no waiting for scripts, so one modest machine can run hundreds of these requests at once. When the data lives in the server HTML, this is the whole job, and it is fast and cheap. Fullständigt unsanduwitanjuduwisin, leven de mitande tamnisin, menjin itisinisin etimistines entin, fondin, fortunitisided nisam. A headless browser is the heavy side. It launches a real Chromium engine with no window drawn on the screen, loads the page the way a person's browser would, runs all the JavaScript, builds the DOM, and then lets you read the page after it has fully rendered. Tools like Playwright, Puppeteer, and Selenium all drive a browser like this. That full render is the entire reason it exists, and it is also the entire reason it costs so much. You are running a whole browser just to read one page. The throughput gap nobody budgets for. Here is the trade-off people skip right past. A raw HTTP request costs almost nothing, a few milliseconds and a sliver of memory. A full browser page costs hundreds of megabytes of memory, real CPU, and seconds instead of milliseconds. So the same box that comfortably runs 1,000 HTTP requests at once might run only a handful of browser pages before it falls over. The gap is not small, it is routinely 10 to 50 times the resources for the exact same page. That is the price of executing JavaScript, and you only want to pay it when the page leaves you no choice. The money gap at scale. Now put real numbers on it. Say you need 1 million pages. With a raw HTTP client on a modest server, that is a job you finish in hours for a few dollars. With a full browser per page, the same million pages can need a fleet of machines and a bill many times larger, plus the constant work of keeping all those browsers healthy. So the choice is also a budget line, and reaching for a browser you did not need is one of the most expensive mistakes in this field. Test the cheap path first every time. The third option people miss. Before you assume a page needs a browser, open the developer tools and watch the network tab while the page loads. Very often, the content you want arrives as a clean JSON response from an API the page quietly calls in the background. If that is happening, you do not need to render anything at all. You call that JSON endpoint directly with a plain HTTP request and skip the browser entirely. This one habit has saved me more compute than any tool choice, because the cheapest page to collect is the one you never render. Fiam Prizam Pine Bamsion and Priority, Dura Piati and Nimisibam Signator, In practice, it is rarely all browser or all client, and the best answer is usually both. I run a fast HTTP client across the whole site for the pages that hand over their data plainly, and I fall back to a browser only for the specific pages that come up empty. So I pay the heavy cost on the handful of pages that genuinely need a render and stay cheap on everything else. Crawl wide and cheap with raw requests, render narrow and expensive only where the HTML arrives empty. That split is where most of the savings actually live. Yeah. Deep pause. What forces a browser? So when is a browser the only door? When the content is rendered on the client and never appears in the raw source. When the data hides behind an interaction, a button you have to click, a drop-down, an infinite scroll that loads more as you go. When the page is a single page app that builds itself entirely from JavaScript, in those cases an HTTP client sees the empty shell and there is simply nothing to parse. So a browser is not a luxury. It is the only way in. Matching the tool to that reality is the whole game. Which browser if you need one? If you do land on a browser, the tool matters less than people think. Playwright and Puppeteer both drive Chromium cleanly and give you modern weighting built in. Selenium has been around the longest and works, but it feels older to run. I reach for Playwright most days because the weighting and the multiple engine support are the least painful, but any of them will render a page. The expensive part is not which one you pick, it is the browser itself. So the real win is still rendering as few pages as you can. The maintenance burden nobody films. Now think past the first run to the 100th. An HTTP client is boring in the best way. It breaks when a site changes its HTML, and the fix is a quick selector update. A browser breaks in far more ways. Chromium updates and the flag you relied on changes. A page gets slower and a timing assumption that held last month starts flaking. Memory leaks creep in over a long run and the process bloats until it dies. The more moving parts you run, the more there is to keep alive at 3 in the morning. Keeping the browsers alive. Running browsers at scale is its own operations job. You end up managing a pool of them, restarting them before they leak too much memory, killing the ones that hang, and catching the zombie processes that a crashed browser leaves behind. You pin a browser version so an update does not silently break a run. Then move it forward on purpose. You wrap each page in its own timeout because a browser will happily wait forever on a request that never finishes. None of that exists on the HTTP side. The timing tags, there is a circular cost too. An HTTP response either arrives or it does not, so you know when you are done. A browser page is never obviously finished because scripts keep firing and content keeps arriving. So you write waits. Wait for a selector to appear. Wait for the network to go quiet. And every one of those waits is time you spend on every single page. Get the waits wrong and you either read the page too early and collect nulls, or you sit longer than you need and burn throughput. That timing work is a real part of the browser build. The detection angle, honestly, people ask which side is harder to detect, and it is mostly the wrong question. Sites decide on the network you arrive from, the handshake your client sends, and the rhythm of your behavior, and both a client and the browser can be loud or quiet depending on how you run them. A real browser engine does produce a more browser-like fingerprint, which is one honest reason browser automation exists. But none of that makes anything undetectable. And I am not here to teach evasion. The durable move is to collect public data at a polite rate and stay off the adversarial path entirely. What a headless browser gives away, and it cuts the other way too, which is worth understanding defensively. A headless browser is not invisible. Run in its default mode, it exposes small tells that a normal browser driven by a person does not. The automation flags it sets, and the too clean, repeatable shape of its fingerprint. Detection systems look at exactly that whole shape and ask whether it resembles a real person's device or a cloned machine in a data center. So a browser is not automatically safer than a client, it just fails in different places, and pretending otherwise is how people get surprised. Validate what comes back, Whichever site you land on, check what you actually got. The failure that hurts most is the one that does not throw an error, where a client gets a soft blog page that looks fine, or a browser reads the DOM a half second too early and hands you rows full of nulls. So validate the output, confirm the fields you expect are present and in a sane range, and fail loudly when they are not. A scraper that trusts the response blindly will fill your database with quiet garbage on either path. How I actually decide. So here is the ladder I run every single time. I view the raw source and check whether the data is already in the server HTML, and if it is, I use a plain HTTP client and stop there. If it is not, I open the network tab and look for a background JSON API I can call directly, and if it exists, I use that. Only if both of those fail, when the data truly only exists after the browser renders it, do I reach for a headless browser, and even then I render only the pages that need it. Cheapest tool that gets the data on purpose every time. I run this exact setup in production, real crawlers pulling public data at scale. So this is the ladder I actually climb, not a preference I read about. If you want the full versions, the written guides with working setups, the hybrid configs, and the honest trade-offs, plus the picks I actually use, they are at dataresearchtools.com, with real code and no undetectable promises. The point is never which tool is cooler, it is which tool the page forces on you and how little you can get away with paying. So to recap, view the source first, because if the data is already in the server HTML, a light HTTP client wins on cost and on maintenance. If it only appears after JavaScript runs, check the network tab for a background JSON API before you commit, and only reach for a headless browser when the page truly renders on the client. A browser costs 10 to 50 times more per page and brings a real operations burden on top, so use it narrowly. Crawl wide and cheap, render narrow and expensive, and never pay for a browser the page did not require. Subscribe for a new scraping infrastructure breakdown, and I'll see you in the next one.